Okay, so trig. All right, so let's talk about a trig curve. How do you graph a sine curve? Where does it start? In the middle. And then where should I go after that? Up. Do you remember if I do degrees? So that's 0 degrees. This would have been 90 degrees. Do you remember? At 90 degrees, what's the sine value? 1, right? Okay, and then at 180, right? Back to 0. All this coming back. 270, -1, and 360, back to 0, and on, whatever. Okay, what if I threw a 45 degree in there? Do you guys know the number for the sine of 45 degrees? √2/2. Okay, just for a graph's sake, can I do this? √2/2 is 0.7-ish. Okay, do you like that curve? Okay, now cos. Where does cos start? Top. So 0 degrees. All right, that's the 90, 180, 270, 360. Okay, now here's the rules. The derivative of sine is cos. So if you have a sine function, the derivative is cos. Okay, so here's what it looks like. For instance, let's go to 90 degrees on a sine. Okay, how do you draw the tangent line? At 90 degrees, it would look like horizontal. What's the slope exactly? 0. Okay, go to the cos curve. Go to 90 degrees. What's the height? 0. Interesting. Okay, let's go to 180. Okay, if I drew a tangent line, this might not be very good, I'm sorry, I'm going to try. I'm going to draw a tangent line. I don't know, I'm going to try. Okay, there's my tangent line at 180. What's the slope of it? Okay, we'll go to cos. The slope of this pink line is -1, because what's cos? -1. Look at that. See how that's connecting? Okay, now here's the other way around. If you are a cos function, the slope is negative sine value. Okay, so for instance, I'll go to 270 here. If I did a tangent line like that, the slope is +1. Okay, so here's the formula opposite of the sine. So what is the sine of 270? -1. Does that have a -1 slope? No, it has +1. So that's why there is a negative sign in front. Anybody? Aha, this is cool. Connects. Will show some calculus emotion. No, not cool. Okay. So that's just the background of like what's going on, why, what is it connecting to. Okay, so otherwise it's just rules. Okay, so notes wise, so what did we say here? when you have a sine function, you derive it to be cos. If you have a cos function, you derive it to be negative sine. Okay, do you remember what we did last time? We had like a bracket family. We called it u instead of just an x. So when we derive this, we're going to do cos. The derivative of sine is cos, but then we're going to attach a chain, which is the family's derivative. Okay? Okay, same thing here. So if there's other stuff, we're going to go negative sine of it and then attach the derivative of that family. So that's that chain. So we're doing a trig property and then the chain property. Okay, so here I go. If y equals x squared, y prime equals cos of x squared. Now I have to attach the derivative of that unit, which is 2x. Okay, so it's very similar to other things we've learned. Okay, y prime equals. So if I'm a cos, I'm going to derive it as a negative sine of that unit and then attach the derivative of that unit. Okay, on the third example, I would take it as a product. Okay, I'll do it the long way, and then I think the next one we'll do it as a short way. So, do you see my two things? I'm going to do a product. Is that okay? I've highlighted them there. Okay, here we go. What is the derivative of this blue? 0 times the original plus, okay, so I derived my blue, kept the pink, so then now I have to keep my blue one and derive this pink one. So it's a sine. So I'm going to go cos 9x. Then I have to attach the derivative of that family, which is, what's the derivative of just the 9x portion? 9. Okay, so this is going to not exist. And can I simplify this to be 72 at least? I know I normally don't say to simplify, but that's a pretty simple simplifying. I think you guys can handle that one, right? Simplifying 8 times 9. Okay, so can we understand that this part just doesn't exist? And just start here on the next one? Is that okay? Y prime equals 10. So I'm going to keep that and derive this. Okay, so I'm a cos. So I'm going to go negative sine of it. Negative sine of that family. Attach the derivative of that family, 6x. Okay, you probably would see my answer a little bit simplified here. I would put maybe like that together or something in the front. So 10, negative 1, 6, I would go negative 60x. I don't know. You might see my answer key something like that. I don't think I'm asking you on the test to simplify. So, probably like this one, maybe. I expect that of you, but it'll get crazy and then you won't have to. But okay. Ready? You're gonna start with the chain rule. This is a chain rule. So this was yesterday's. I'm gonna say, what's the front times the top? 5 of those to the 4th. Now I have to attach the derivative of that. What's the derivative of doing something with sine? Cosine it. But then I have to attach the derivative of that. So you have two chains going on. Did you see that? I chained using the exponent rule, and then I chained my trig item. Yay, nay, do we like the sounds of that, or is that confusing if I say it like that? I chained the exponent rule, and then I chained on my trig item. Okay, so this is how it gets a little tricky when you're combining like 3 rules. Okay, here we go. Do you guys know that this written out could also equal right? That's the same meaning. Okay. It is not the same as this. Right? This does not mean the same thing. That's not. Do you remember? We talked about it more like this. That does not mean the same thing. Right? This does not mean the same thing. Do you remember that from pre-calc? This and this mean the same thing. This does not. Okay? What this means is to figure out the sine trig value and then square that trig value. What does this mean? Square the angle and then figure out the sine of that big angle. Okay? Okay, so ready? Here we go. Chain rule. What's the front times the top? 4 of those to the 3. So that's my exponent chain rule. Attach the derivative of this family. So the derivative of the family is doing a trig rule. So now what's the derivative of sine? Cos x cubed. Attach the derivative inside the trig. So there's chain, attach it, okay? Okay, so this one, sorry, I'm just rewriting it because my staple is in my way. Okay, this is a product. You see a product out of this? So I'm just going to give myself some color here. There's one thing and there's 2 things. Okay, here we go. Product rule. Derive times keep. Derive times keep. Good. plus keep times derive. So deriving the sine is cos x cubed attach 3x squared. Okay, how does that seem? Okay, I'm going to give you one little thing to think about here too. What if I did some blank paper here? What if I gave you tan theta? What else is tan theta all about? Sine over cos. What are you going to do to derive this? Quotient rule. Got it? That's something to think about. I'm not going to do it, okay, because you're going to think about how to do this quotient rule. Derive this times keep that minus keep that, derive that over cos squared, right? Could get crazy. Then, can I make you think about like some of those trig things here? No. I think this is maybe one that you might have to think about here. Do you remember that one? So you said you wanted to do trig proofs, so here it is. This one. Okay, you got that one? That one's the easy one. Sine squared cos squared makes a 1. And you can, if you find that, wink wink on your paper somewhere. Okay?